In this tutorial, you are going to learn basic concepts in operators in Python 3. In this tutorial, you will learn everything about different types of operators in Python and their syntax. And with some examples, you will going to learn the table of contents, what are operators in Python, arithmetic operators, comparison, logical, wise, assignment operators, special operators, identity operators, membership operators, and finally you will be going to learn about operators precedence. What are the operators in Python? Operators are special symbols in Python that carry out arithmetic or logical computation. The value that operator operates on is called the operand. Let us take the example here. 2 plus 3. Here 2 and 3 are the operands, plus is the operator, and 5 is the output. Types of operators: arithmetic operators, comparison or relational operators, logical operators, bitwise operators, assignment operators, special operators, in that identity operators, membership operators. Arithmetic operators. Arithmetic operators are used to perform mathematical operations like addition, subtraction, multiplication, etc. etc. Here, plus, minus, multiplication, division, percentage, modulus, exponent, and floor division. These are the basically arithmetic operators. Using these operators, we will be able to perform some mathematical operations. Let us take a variable a is equal to 10, b is equal to 21. If you add these two variables like this, a plus b is equal to 31, a minus b equal to minus 11. Let's see the programming part. Open the idle. Let us take the value a equal to 10, b equal to 21. Now the arithmetic operation addition, a plus b equal to 31, just like this. Now the subtraction operation, a minus b is equal to minus 11. Similarly, multiplication, a into b is equal to 210. Okay. Now division operation, what is that? B by a. Let us divide the variable b with a. Now its output is 2.1. Now modulus, b percentile a, it gives the 1. Why? Because here b percentile a, here the result is the remainder of the result. Okay. Similarly, let's take a equal to and b equal to 3. Let us assume, just for this exponent purpose, a double star b. This is the exponential operation. Here 2 to the power of 3, it gives the result 8. Now let us assume a variable with 9, b variable with 2. Now floor division, we will see the a floor division b, it gives 4. Actually, if you divide the a with b, 2 into 4 is equal to 8. Then 4 is the here quotient. it returns the quotient value. Okay. In comparison operators, these comparison operators are used to compare values. It either returns true or false according to the condition. These operators compare the values on either side of them and decide the relation among them. So it is called the relational operators. Now see the operators. Double equal to and this one exclamatory and equal to, greater than, less than, greater than or equal to. These are all the comparison operators. Let's see the programming part, how to use this. Okay, go to idle. Let us take one example here. A equal to 10. Let us assume A equal to 10 or B equal to 20. A double equal to with B. It is true or false? Here double equal to is the, if the values of two operands are equal, then the condition becomes true. This is if you use this double equal, A value is 10 and B value is 20. So these are not equal. So the result is the false. It returns the true or false in comparison operators. Okay. Now we will check next one equal to B. In this condition, if the values of two operands are not equal, then condition becomes true. This is not equal to B. A is not equal to B. Yes? Yes, it is true. Similarly, A is greater than B. It returns false. Why? Because A is equal to 10 and B is equal to 20. So it returns false. A is less than B. Then it returns true. So it compared the A value with B and returns the result. That is true. Okay. If you compare the next one, A is greater than or equal to B, it is false. Similarly, A is less than or equal to B, it is true. Okay, these are the comparison operators. Now next, logical operators. In logical operators, and or not, and or not. These three are the logical operators. If you use this operator and, if both operators are true, then condition becomes true. For example, let us take two variables, A equal to true and B equal to false. How the Python interpreter checks? There is a truth table for this and or not here. This is the and truth table, this is the or truth table, this is the not truth table. Here the Python interpreter checks the truth table. For example, A is equal to true and B is equal to false. Using this and logical operator, if both are true, the result is true. If any one of the variable is false, it gives false. See here, in these two conditions, it returns false. If both are the false, then it returns false. Similarly, in our OR truth table, both are true, it gives true. Any one is true, it gives true. In these two conditions, it returns true. If both are false, it gives false. Similarly, not truth table. This is for not. If A is true, it gives false. If A is false, it returns true. Now, see the programming part. Let us assume A equal to value true, B is equal to false. Now, check the condition A and B. Here, and is the logical operator. it checks the logical. This is false. Why? Because A is true, B is false. If you use this truth table, A is true and B is false, it returns false. Okay. Similarly, A or B, it returns true. Why? Here, A is true, B is false. Then it returns true. Similarly, check not A, it returns false. Because A is given the value with true, but if you use this logical operator not, it returns false. One more example here. True and false. True is a variable, let us assume, and false is a variable. If you take and is a logical operator, it gives false. Now true or false, it gives true, like this. Now not false, it returns true. Okay. Now next one is the bitwise operators. Bitwise operators act on operands as if they were string of binary digits. It operates bit by bit. Hence, the name is bitwise operators. Here in Python, built-in function bin parenthesis. This is used to obtain binary representation of an integer number. Let us assume a value with 60, and in binary notation it is in 8-bit notation 00111100. This is the binary notation. Similarly, b, if you assume b value with 13, its binary notation is 00001101. Okay, these are all the bitwise operators, and or XOR, ones complement, binary left shift, binary right shift. Let us see the programming part. Example, a value has taken 60. How to convert this integer value into binary? Just now seen binary of a. It gives, this is the 0b, 0b is the binary notation 111100, just like this. Okay. Now take b value with 13. If you convert this b value in binary notation, it gives 0b1101, like this. So we will check the bitwise operators. For example, if you if you use binary and a and b, it's 12 is the integer number notation, but to get the binary notation, just simply use bin of a and b. Just simple type, you will get the 1100. See here, a and b is the 12 is the integer part, and this is the binary notation 1100. Okay, all these are all zeros, so it is not showing here, but remaining part, this is 1100, it shows here output. Similarly, a or b. Next one is the binary r. Okay, this is the pipeline. It gives 61 value in the integer part. See here, integer part. If you convert it into binary, a or b, it gives the 111101. See here, 111101. This is the output. Similarly, a XOR b, it is the 49 is the output. See here, 49, and convert into the binary notation. 11 1 0 1. See here, 11 0 0 1. Okay. Now we will see the binary ones complement. This is using the tilde. A equal to 60. Binary of A is 11 1 0 0. We will complement A using this first tilde. A is equal to 61. This one, like this. If you want in binary notation, it will give this one minus 00 11 11 0 1, like this. Okay. Now we will see binary left shift. For example, A is left shift with two places. Then it gives two party, like this. For example, if you see in binary, A is left shift with the two places. This is the 11 11 00 00, like this, 11 11 00 00. Okay. Similarly, binary of right shift, A is in right shift in two places. It gives 15, like this. See, if you take in binary notation, left 11 11, like this. Okay. These are the binary operators. Now we will see assignment operators. Assignment operators are used in Python to assign values to variables. For example, A equal to 5. It is a simple assignment operator that assigns the value 5 on the right to the variable A on the left. There are various compound operators in Python, like plus equal to, minus equal to, star equal to. These are the compound operators. This is the assignment operator. Now see the programming part. A value with 10 now, B value with 20. A and C value with 0. C equal to A plus B. Now print C. Here A is 10, B is 20. It gives the output 30. To 30 result is assigned to the variable C. Okay. Now we will check the condition. Next assignment operator, plus equal to C plus equal to A. Here it means C equal to C plus A. The interpreter assumes this notation like this, C equal to C plus A, like this. Okay. Now print the value of C. Here C value, here C value is the 30. Earlier it got 30 result, and A value is the 10. 30 plus 10 is the 40. It is assigned to the C, the new value. Now C is updated with the value 40. Now see the next subtract and assignment operator. C minus equal to A. It means C equal to C minus A. The interpreter assumes like this, C equal to C minus A. Here C is the value 40 and 10 is, A is the value 10. 40 minus 10, it gives 30. Now check the value C. C is the 30. Okay. Now check the multiply and assignment operator. C star equal to A. Here the interpreter assumes C equal to C star A. The value here C is updated with 30 and A is the 10. 30 into 10 is the 300. The result 300 is assigned to the variable C. Now we will check divide and assignment operator. C divide and A. The interpreter takes it as C equal to C by A. Here C value is 300, A value is 10. The result is the 30. If you check the value 30, 30 is the new value assigned to C variable. Similarly, modulus and C modulus equal to A. Here the interpreter assumes C equal to C percentile A. Now check the value of C. C equal to 0. Okay. For example, C has taken variable with 2. Now check this modulus and operator. C percentile equal to A. It takes C equal to C percentile A. Here C is the new variable 2 assigned and A is the 10. Now check the value 2 because it returns reminder 2. Okay. Now check the exponent and operation. C double star equal to A. Here the interpreter takes it as C equal to C exponent of A. Here C value is assigned with 2 and A is the 10. 2 to the power of 10 is equal to 1024. This is the 1024. Take fluoro division and this one. C double fluoro division and A. The interpreter assumes C equal to C fluoro division of A. Here it returns quotient only. The value of quotient. Here C is assigned with 1024, A is 10. The 102 is the quotient of. Okay. Now we will see special operators. In special operators, Python language offers some special type of operators like the identity operator and membership operators. First one is the identity operators. Identity operators are used to check if two values or variables are located on the same part of the memory. Two variables that are equal does not imply that they are identical. Let's check these conditions. Let's check these identity operators. Identity operators compare the memory locations of two objects. They are two identity operators like this. Is and is not. These two are the identity operators. Is here is evaluates to true if the variables on either side of the operator point to the same object. Otherwise it is false. X is y. Here is results in 1 if id of x equals id of y. Okay. Is not. This is the identity operator. It evaluates to false if the variables on either side of the operator point to the same object and true otherwise. X is not y. Here is not results in y. If id of x is not equal to id of y. Okay, let's see the programming part. Let us assume a value with 20, b value with 20. Now see the id of a. This is the id of a, memory location. Similarly, id of b. This is also same as a. Why? Because a and b are assigned with the same constants 20, 20. Those locations are same. Okay. Now check the identity operators is not like this. A is b. A is b. Here is IDs of both A and B are equal, then it returns true. Okay. ID of A, ID of B. Let's check the equality condition. It is also true. Both IDs are here, see here, are equal. So it returns true. Now take the variable B with 30. Earlier it is B is 20. Now B is updated with the value 30. Then check the condition. A is B. It is false. A and B are not equal. And check the ID of B. B is this one. Earlier it is this one 5046170056. But ID of B is now changed to this one. Now ID of A, it is 5046170056. Same memory location. It is not changed. But ID of B is changed. Now check the ID of A with the ID of B. It is false. Both memory locations are different. B and A memory locations are different. So it returns false. Similarly, A is not B, the second identity operator. It is true. Here both memory locations are different. But A is B, it returns false here. A is not B, it is true. Okay. Now check the one more example here. X1 equal to, for example, 5. Similarly, Y1 is equal to 5. Similarly, X2 value, let us take hello. Y2 value hello. Now X3 value 1, 2, 3. Y3 value also same. 1, 2, 3 are the list values. Okay. Let's see. Now check the identity operators. Let's see ID of X1. This one. ID of Y1. X1 and Y1 IDs are both are same. Why? Because it is filled with the same value 5. Okay. Now it has to, if you check the is operator, X1 is Y1, it has to return true. Okay. Now check x1 is not y1, it returns false. Why? Because x1 and y1 IDs are same. If you check with is not, it returns false. Now check x2 is y2, it returns true. Why? Because the x2 is the string hello and y2 is the string hello. Both are IDs are equal, then it returns true. x2 is not y2, it returns false as usual. Now check important next one, x3 is y3, it returns false. Why? See here, x3 and y3 x3 and y3 are list. They are equal but not identical because the interpreter locates them separately in memory so that they may be equal, but it locates in the memory separately so that x3 is y3, then it returns false. Here is it compares these x3 and y3 IDs. So IDs are different. Why? Because check the ID of x3, this one. Similarly, ID of y3. See here, 37787 527 These two IDs are different. Why? Because x3 and y3 are the list values. They are different, separately located in memory. So that if you use the is ident operator, it returns false. Similarly, x3 is not y3, it returns true, obviously. Okay. Now we will see membership operators. These are used to test whether a value or variable is found in a sequence: string, list, tuple, set, and dictionary. In a dictionary, we can only test for presence of key, not the value. The membership operators are in and not in. In. The in operator evaluates to true if it finds a variable in the specified sequence. Otherwise, it is false. Similarly, not in. It evaluates to true if it does not find a variable in the specified sequence. Otherwise, it is false. Let's check these membership operators in programming part. Let's see. X value, let us take x value with 10, y value with 20. And list, take one list here, 1 2 3 4 5. Okay, let's check the membership operator in. X value in list, x value is 10. Is it available in list? No, it returns false. Similarly, y in list, it returns also false. Okay, x next operator, x not in list, it is true. Similarly, y not in list, it is also true. Now see, for example, z equal to y by x. Okay, the y value is divided with x. Y is 20 by 10. 20 by 10, it is its output value z is equal to 2. Okay, now check the membership operator for z value. Z in list true. Why? Because z value is 2. 2 is available in the list. Similarly, z not in list, it is false. Why? Because z values 2 is available in the list values. Okay, now check one more example. X equal to hello world and y value equal to dictionary. 1 is to a, 2 is 2 is to b. These are the dictionary values. Sorry, y value 1 is to a, here comma 2 is the key and its value is the b. Now we will check the membership operators. H is in x, print H in x true. H is available in list in the string value of x, so it returns x. Similarly, print hello not in x, it is true because h small h, here capital H, both are different, so it returns true. Similarly, print 1 in y true. Why? Because 1 is the key value, key, it is available in y's y dictionary of y. Similarly, print of a in y it is false. Why? Because the membership operators checks for the key values only, keys only. It does not check value pairs. Okay, now last one is the Python operators precedence. Now the following table lists all the operators from highest precedence to the lowest. The operators with the highest precedence appear at the top of the table. Those with the lowest appear to the bottom. This number 1 is the highest priority. First priority, Python interpreter gives the exponentiation, next complementary, unary plus and minus, and next third priority, multiplication, division, modulus and floor division, addition. Next fourth one is the fourth priority is the plus and minus, and next right and left bitwise shifts. These are all the given in the highest precedence to the lowest precedence. Here, for example, if you given x equals 7 plus 3 into 2, it first multiply these two variables, 3 into 2, 3 into 2 are 6. Next it adds with 7. Why? Because this is the here you have given the multiplication symbol. The multiplication is the highest priority than the plus. Here is the plus, here is the multiplication. This is the third priority, this is the fourth priority, so that it first multiplies with these two variables, and next it gives next it adds with the this variable. Now let's see the programming part. For example, A equal to 20, B equal to 10, C equal to 15, D equal to 5. All these four variables we are going to use in this example. First one is the E equal to A plus B. Next, it multiplies with C by D. Here A plus B is given in bracket. The A is 20 and B is 10. So it is the 30. Next, it multiplied with C value is 15 by 5. Here multiplication, division, these are the third priority, and plus and minus are the fourth priority. So here 15 by 5 it gives 3. Next it multiplied with 30. Then the result will be E value is 90. See here. Now check one more condition. E equal to A plus B into C by D. It is also same thing. A plus B is the 30 multiplied with C value is the 15, then divided by 5. C value is the 15, D value is the 5. Here first it multiplied, next it will be divided. 30 into 15, 450 by 5, it gives 90. Now check one more example. E equal to A plus B multiplied with C by D. Here also same thing. A plus B is the 30. Next C by D. What C by D? 15 by 5 into 3. So it gives the same result, 90. And next one, last example. E equal to A plus B into C by D. Here A is the value 20 plus B into C 10 into 15. First it multiplied 150, then divided by D is the 5 value. First 150 by 5, it is the value, it gives the result 50. Finally it adds. Why? Because division is the highest precedence than plus. So 150 by 5 is the 50. Finally it adds with 20. Then it gives the result 50. Okay. Okay friends. In the next tutorial, we are going to learn about the namespace and scope in Python 3. If you like these tutorials, please subscribe this channel, friends, and please give your feedback. Thank you for watching. Please see this tutorial lesson available in PDF file. The link is given in the description. Please download it for the reading. By signing off, Kishore Kumar Vajja.